In question 1, we've got f of x here, a cubic polynomial in x, and we need to find f dash dash of x, so the second derivative with respect to x. So let's start with the first derivative. F dash of x is 3x squared plus 4x minus 8, which means that f dash dash of x, the second derivative, is simply 6x plus 4. In BI, we need to solve f dash dash of x is equal to 0. So let's start by setting what we just obtained in part A. 6x plus 4 is equal to 0, which means that 6x is equal to negative 4. So x is minus 4 over 6, which simplifies to minus 2 over 3. In II, it says hence find the range of values of x for which f of x is concave. Well, a curve is concave if the second derivative is less than 0, or you could also say less than or equal to 0. So here we simply need to solve the 6x plus 4, which was the second derivative, being less than 0. So we get that 6x is less than negative 4, which means that x is less than negative 4 over 6. So we've got x being less than minus 2 over 3. And of course, the examiner is also accepting here x being less than or equal to minus 2 over 3. So a strict or a relaxed inequality are both acceptable. In question 2, we've got this sequence starting at 35 being defined recursively through this recurrence relationship, and we need to show that u2 is equal to 40. Well, let's start by stating that u2 is equal to u1 plus 7 cos of 1 times pi over 2 minus 5 times the negative 1 to the power of 1. So n is 1 here. So this means we're looking at 35 plus 7 cos of pi over 2 minus 5 times the negative 1. And this gives an answer of 40 as required. We are then told to find the value of u3 and u4. So we can continue in this way. We will find that u3 gives a value of 28 and u4 gives a value of 33. In part B, we are told that the sequence is periodic with order 4 and we need to write down the value of u5. Well, if we've got a periodic sequence, then this means that it repeats, and if it has an order of 4, it means that every 4 terms we've got a repetition of the pattern. So this simply means that uk is equal to uk plus 4. So in our case, u5 is equal to u1, and we already know that u1 is 35, which means that u5 is 35. In II, we need to evaluate the sum of the first 25 terms. So the sigma notation represents the sum here. We've got the sum of ur from r equals 1 up to 25. So this means we've got u1 plus u2 plus u3 plus u4 plus u5 plus dot 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 plus u24 plus u25. Well, if we exploit the fact that we're looking at a periodic sequence with order 4, we can see that from u1 up to u24, we've got 6 periods, so 6 repetitions of the pattern. So we know that the first 4 terms are 35, 40, 28, and 33. So I've got 6 times this sum plus the 25th term, which is essentially the first term of a new period, so it must be 35, just like u1. So if I plug this on the calculator, I get an answer of 851. In question 3, we need to start from the logarithmic equation given here to arrive at this quadratic equation in x. So starting with the log of x plus 3 plus log of x plus 10 is equal to 2 plus 2 log x and everything base 2. We can combine the left-hand side into log of x plus 3 times x plus 10, because we know that when we've got addition of logarithms, this simply means that we have the logarithm of the product is equal to 2 plus log of x squared base 2, because through the power law of logarithms, the 2 can go up as a power. So I will collect all the logs on the left-hand side to get log of x plus 3 times x plus 10 base 2 minus log of x squared base 2 is equal to 2. And then I can combine the left hand side into a single logarithm. We've got log of x plus 3 times x plus 10 over x squared and everything base 2 is equal to 2, which means that x plus 3 times x plus 10 over x squared is equal to 2 to the power of 2. So I have removed the logarithm. I will expand the numerator on the left hand side to get x squared plus 10x plus 3x plus 30 over x squared is equal to 4. So if I cross multiply, I get x squared plus 13x plus 30 is equal to 4x squared, and collecting everything on the right hand side will give me 0 is 3x squared minus 13x minus 30 as required. In BI, we need to write down the roots of this equation here. So what I can do is simply get my calculator and use it to solve automatically the given quadratic equation. So I press menu, it's option A, it's a polynomial, so option 2 of degree 2. So we've got the coefficient of x squared being 3, the coefficient of x being negative 13, and the constant term being negative 30. So I plug everything on the calculator. So I get the two solutions to be either x is 6, or alternatively, if I press the equal sign, I see the second solution is minus 5 over 3. And in II, we need to state which of the roots obtained is not a solution to the original logarithmic equation. We're looking at the original equation here. We can see we've got some restrictions. We need the x plus 3 to be greater than 0. We need the x plus 10 to be greater than 0. And we also need the x to be greater than 0 because we've got the logarithm of something positive to be well defined. If we've got the logarithm of 0, the logarithm of a negative number, then this is a math error on the calculator. So this means we need x to be greater than negative 3. We need x to be greater than negative 10 and x to be greater than 0. And we can easily see that these three inequalities are satisfied when x is greater than 0. So any valid solution should be positive. So since we need x to be greater than 0, then the solution of x being negative 5 over 3 is not a valid solution. In question 4, we've got coffee being poured into a cup. We've got a model for the temperature of the coffee H degrees Celsius T minutes after being poured into the cup through this equation here. Now, initially the temperature was 85 degrees Celsius and we need to state the value of A. So we've got that when T is 0, the initial temperature was 85, so capital H is 85. So I will substitute in the given model to get 85 is A e to the minus B times 0 plus 30. So we've got 85 is equal to A plus 30, which means that A is 55. In part B, we are told that initially the coffee was cooling at the rate of 7.5 degrees Celsius per minute, and we need to find a complete equation linking H and T, giving the value of B to 3 decimal places. Well, let's start by stating the equation as it stands with the value of A we just obtained. So H is 55 e to the minus BT plus 30. So since we are told that we are cooling at a rate of 7.5 degrees Celsius per minute, this means we need to look at the derivative. So we've got dH dt is equal to 55 times the negative b, which is the derivative of the exponent here, e to the minus bt plus 30. So this is minus 55b e to the negative bt plus 30. Now, initially we were cooling at the rate of 7.5 degrees Celsius. So dH dt when T is 0 was negative 7.5. Well, it's negative because the temperature was dropping, the cup was cooling down. So this is equal to minus 55b e to the 0 plus 30. So we've got minus 7.5 is minus 55b plus 30, which leads to 55b being equal to 37.5, and therefore b turns out to be 3 over 22, which correct to 3 decimal places as instructed is 0.136. Well, we need to find a complete equation here, so the final line here to score all marks will be that capital H is equal to 55 e to the minus 0.136t plus the 30. In question 5, we've got the curve C with equation y is f of x passing through the point P with coordinates 3, -10, and has a turning point at this point P. Additionally, we've got the expression for dy dx, and we need to show that the constant k turns out to be 12. So let's start with the fact that we've got a turning point at P, which simply means that dy dx at x is 3. The x coordinate of P must be giving a result of 0. So I will be substituting here x with 3. We get 2 times 3 to the power of 3 minus 9 times 3 squared plus 5 times 3 plus k is equal to 0. So this leads to -12 plus k is equal to 0, and therefore we obtain that k is 12 as required. In part B, we're asked to find the coordinates of the point where C crosses the y-axis. So we have already established the full expression for dy dx now that we know that k is 12, and we need to integrate to go back and find y. So y is the integral of 2x cubed minus 9x squared plus 5x plus 12 dx. So in integration, we increase the power by 1, divide by the new power. So we get 2x to the power of 4 over 4 minus 9x to the power of 3 over 3 plus 5x squared over 2 plus the 12x plus the constant of integration c. So let me start by simplifying. The 2 with the 4 leaves me a 2 in the denominator. The 9 with the 3 leave a 3 in the numerator, which means we're looking at y being x to the power of 4 over 2 minus 3x cubed plus 5x squared over 2 plus 12x plus c. Additionally, we've got that point P has coordinates x is 3 and y is -10, and I'll be using these to determine the constant of integration c. So this means we've got -10 is equal to 3 to the power of 4 over 2 minus 3 times 3 to the power of 3 plus 5 times 3 squared over 2 plus the 12 times 3 plus c. So we get the -10 is equal to 18 plus c. So minus 28 is the value for c. So we're looking at the point where we cross through the y-axis. If I'm crossing through the y-axis, that means that x is 0. So if x is 0, all of these disappear. Y is simply c, which we found to be -28. And therefore we conclude that the point has coordinates 0, -28. In question 6, we are given the position vectors for points A, B, C, D, and we need to show that AD is parallel to BC. So I will start by finding the vector AD. So it's always the second letter minus the first letter. So the position vector of D is 22, 24. The position vector of A is 12, 0. This turns out to give me a result of 10, 24. I will similarly find the BC vector, which is the C, the 50, 136, minus the B, which is the 0, 16, which gives an answer of 50, 120. Now we observe that this is simply 5 times the AD. So we see that the BC is a multiple of AD, and therefore we conclude that AD is parallel to BC as required. Now the points A, B, C, D are used to model the vertices of a running track in the shape of a quadrilateral, and we've got the runners completing a lap by running along all 4 sides of the track. Now we've got all measurements in meters, and we've got a particular runner taking exactly 5 minutes to do 2 laps, and we need to calculate the average speed of this runner. Well, I will first start by determining the total distance for 1 lap. So I will find the vector AB, which is the first side of this quadrilateral. So AB is simply the vector B, which was 0, 16, minus the vector A, which is 12, 0. This gives an answer of -12, 16. And I can proceed in finding the magnitude. So the magnitude of AB is simply the -12 squared plus the 16 squared and all square roots, so Pythagoras here. This gives an answer of 20. Now for BC, we already found the vector BC, so the magnitude of BC will simply be the 50 squared plus the 120 squared and all square root, which gives an answer of 130. And then we proceed with the vector CD. Well, the vector CD will be the vector D, which is 22, 24. minus the vector c, which is 50, 136. This gives an answer of negative 28, negative 112. So to find the magnitude of CD, I will again do Pythagoras. I've got negative 28 squared plus negative 112 squared and all square root, which gives an answer of 28 root 17. And finally, for the DA, the final side of this quadrilateral, it's the magnitude of the vector AD. So it's 10 squared plus 24 squared and all square root, which gives an answer of 26. So this means that the total distance that this runner covered is simply twice the sum of the four sides, because he covered 2 laps. So it's 2 times the 20 plus the 130 plus the 28 root 17 plus the 26. This gives an answer of 582.8939 meters. Remember, we're trying to get the answer in kilometers per hour, so I will divide by 1,000 to convert the distance in meters into kilometers. So I get 0.582839 kilometers. So the speed of this runner is simply the total distance covered. So the 0.582839 kilometers divided by the time taken in hours. Well, he took 5 minutes, so that's 5 over 60 of an hour. So put this on the calculator, get 6.99 kilometers per hour for the speed. In question 7, we've got the curve here defined implicitly, and we need to find the y, dx in terms of x and y. So we need to apply implicit differentiation here, which simply means differentiate from left to right, applying all rules as usual. If you happen to differentiate a term in y, you put the dy dx term as well. So the derivative of x cubed is simply 3x squared. And then I apply the product rule on 2xy. The derivative of 2x is 2, and I keep the y. And then I keep the 2x, and the derivative of y is simply dy dx, plus the derivative of 3y squared, which is 6y dy dx, simply because we're differentiating a term in y, is equal to 0, because the derivative of 47 is a constant, so the derivative is 0. So this means we've got 2x plus 6y in brackets dy dx. So I have factored out the dy dx on the left hand side, is equal to minus 3x squared minus 2y, which means that dy dx is equal to minus 3x squared minus 2y, and all of it over the 2x plus the 6y. Now the point P with coordinates negative 2, 5 lies on the curve, and we need to determine the equation of the normal to the curve at this point, giving our answer in the form ax plus by plus c0, with a, b, and c being integers to be found. Well, the first thing to do is evaluate dy dx at the particular point. So at x is negative 2 and y is 5, which gives an answer of minus 3 times negative 2 squared minus 2 times 5, and all of it over the 2 times the negative 2 plus 6 times the 5, which gives an answer of minus 11 over 13. Well, this is the value of dy dx. This is the value of the gradient of the tangent, and therefore, since we're looking for the gradient of the normal, I need to flip and change the sign. So this is 13 over 11. And we can then use the fact that we've got a point and the gradient. So y minus y1 is mx minus x1. So in our case, we've got y minus 5 is equal to 13 over 11 times x minus the negative 2. I will cross multiply to get 11y minus 55 is equal to 13 brackets x plus 2. And I will expand to get 11y minus 55 is equal to 13x plus 26, which leads to 11y minus 13x minus 81 is equal to 0. In 8a, we need to express 2 cos theta plus 8 sin theta in the form r cos theta minus alpha, where r is positive, alpha is acute, and it's in radians, and we need to give alpha to 3 decimal places. So starting with what we are given, I will be using the addition formula for cos a minus b. So this is r cos theta cos alpha plus r sine theta sine alpha. I can then equate the cos theta terms and then the sine theta terms. So these two must be the same and these two must also be the same. So if I equate the first, I get 2 is equal to r cos alpha and 8 is equal to r sine alpha. This simply leads to 2 over r being cos alpha and 8 over r being sine alpha. I can then draw a right angle triangle as shown. We've got cos alpha is adjacent over hypotenuse and sine alpha is opposite over hypotenuse. So we've got that r is 2 squared plus 8 squared using Pythagoras, which gives an answer of 2 root 17, whereas tan alpha is equal to 8 over 2, which means alpha is shift tan of 8 over 2, which turns out to be 1.326. This means that 2 cos theta plus 8 sine theta is equal to 2 root 17 cos of theta minus 1.326. We then have that the first three terms of an arithmetic sequence are cos x plus sine x, and cos x plus 2 sine x. And we need to find the exact maximum value of S9, the sum of the first 9 terms. Well, let's start by reminding ourselves that the sum of the first n terms of an arithmetic sequence is given by n over 2 times 2a plus n minus 1d, where a is the first term, and in our case, a can be seen to be cos x, and d is the common difference. In our case, it's sine x, because we can see that we add sine x each time to go to the next term. So in our case, we've got that S9 is 9 over 2 times 2 cos x plus 9 minus 1 times sine x. So this is 9 over 2, and we've got 2 cos x plus 8 sine x within the bracket. Well, the 2 cos x plus 8 sine x is exactly what we had in part A. So we can write this as 9 over 2 times 2 root 17 cos of x minus 1.326, which I can expand this to get 9 root 17 cos of x minus 1.326. Remember, we're trying to determine the maximum value that this can attain. Now we know that cos of any angle varies between plus minus 1, and therefore the 9 root 17 times the cosine will vary between plus minus the 9 root 17. This means that we can easily conclude that the maximum value for s of 9 will be the 9 times the root of 17. In II, we need to deduce the smallest positive value of x at which this maximum value of S9 occurs. So we know we can see that the maximum value is attained when essentially we've got cos of x minus 1.326 obtaining the value of 1. This simply means that x minus 1.326 is simply shift cos of 1. So x minus 1.326 is equal to 0, which means that x is 1.326. In question 9, we've got the curve C defined parametrically as shown, and we need to show that the Cartesian equation for C is y is a ln of x plus b, with a and b being integers to be found. Well, I will start by considering the parametric equation for x. So x is t squared plus 6t minus 16. I will complete the square to get x is t plus 3 squared minus 3 squared minus 16, which leads to x is t plus 3 squared minus 25, and therefore we've got that x plus 25 is equal to t plus 3 and all squared. Now we've got that y is 6 ln of t plus 3, and I will actually write 6 as 3 times 2. So we've got 3 times 2 ln of t plus 3. This will allow me to move the 2 up as a power using the power law of logarithms. So this is 3 times ln of t plus 3 all squared. And we have already seen that t plus 3 squared is the x plus 25. So this means that we've got that y is equal to 3 ln of x plus 25. And therefore we conclude that a is equal to 3 and b is equal to 25. We then have that the curve C cuts the y-axis at the point P, and we need to show that the equation of the tangent to C at P can be written in this form, where A, B, and C are integers to be found. Well, let's start by reminding ourselves that we have established that the Cartesian equation is y is 3 ln of x plus 25. If we're looking at a cut on the y-axis, this simply means that x is 0. So in our case, we're looking at y is 3 ln of 25. So we've got this to be 3 ln of 5 squared. So it is 6 ln 5. Now we're looking for the equation of the tangent, so I will need to differentiate. So dy dx will be found by differentiating the inside. The derivative of x plus 25 is 1. So it's 3 times 1 over the x plus 25, because when I differentiate with the ln, it's the derivative of the inside over whatever is inside. So it's 1 over the x plus 25 times the 3 that was outside. So I will evaluate dy dx at x is 0, because we're looking at a cut on the y-axis. So this gives me an answer of 3 over 25. So we've got the gradient, we've got the point. I'm using y minus y1 is mx minus x1. So in our case, it's y minus 6 ln 5 is equal to 3 over 25 times x minus 0. I will cross multiply to get 25y minus 150 ln 5 is equal to 3x, and I will be collecting the x and the y on the left hand side. So 25y minus 3x is equal to the constant of 150 ln 5, which means we can conclude that a is the negative 3, b is the 25, and C is 150 to match the exact form requested in the question. In question 10, we are asked to express f of x in partial fractions in terms of k. So we've got 3kx minus 18 over x plus 4 x minus 2. So since the denominator is already factorized into the two linear expressions x plus 4 and x minus 2, we can propose that the partial fraction decomposition will look something like a over x plus 4 plus b over x minus 2. So the LCM of the denominators is x plus 4 x minus 2, which leads to 3kx minus 18 is equal to a times x minus 2 plus b times x plus 4. So we got rid of the denominators. Now we'll be substituting nice values for x to determine the values for a and b. So we can see that if we put x to be 2, then this will be 0. So setting x is equal to 2 leads to 3k times 2 minus 18 is equal to b times 2 plus 4. So we've got 6k minus 18 to be equal to 6b, and dividing throughout by 6 leads to k minus 3 for the value of b. Now another nice value for x that I could substitute is x being negative 4, so that this becomes 0. So setting x to be negative 4 will lead to 3k times negative 4 minus 18 is equal to a brackets negative 4 minus 2. So we've got minus 12k minus 18 is equal to minus 6a. And if I divide throughout by negative 6, we get 2k plus 3 to be the value of a. This means we can write down f of x as 2k plus 3 over x plus 4 plus k minus 3 over x minus 2. In part B, we need to find the exact value of k, for which this integral gives a result of 21. So we have already expressed f of x in partial fractions. Now the integral of 2k plus 3 over x plus 4 is simply 2k plus 3 in brackets times ln of the absolute value of x plus 4 plus k minus 3 times ln of the absolute value of x minus 2. And this will go from negative 3 up to 1. So I will start by substituting the upper limit. So we get 2k plus 3 times ln of 1 plus 4. The upper limit is 1, plus k minus 3 times ln of 1 minus 2 absolute value, minus the lower limit substituted, which is 2k plus 3 ln of negative 3 plus 4. And then it's k minus 3, and we've got ln of negative 3 minus 2. So This will lead to 2k plus 3, and we've got ln of 5. Now the 1 minus 2 here is simply 1, so this is k minus 3 ln of 1, because we're taking the absolute value, so the negative 1 will give me 1 here, minus the 2k plus 3 times ln of 1 minus the k minus 3, and we've got ln of negative 5, and it's the absolute value here, so it's going to be ln of 5. Now we know that ln of 1 is 0, so this is 0, and this here is 0. So we get 2k plus 3 ln 5 minus the k minus 3 ln 5. Now the 2k minus k gives me k, and the 3 ln 5 minus the negative 3 ln 5 will give me plus 6, and everything is ln 5. And we have been told that this is equal to 21, so k plus 6 is equal to 21 over ln 5, which means that k is 21 over ln 5 minus 6. In question 11, we've got the tank in the shape of a cuboid being filled with water. We've got the dimensions shown here. Now we are told that the rate of change of the volume V is inversely proportional to the square root of h, and we need to show that this leads to the differential equation dh dt is lambda over root h, where lambda is a constant. Now let's start with obtaining an expression for the volume. The volume is simply the cross-sectional area, which is 20 times 10, times the height, which is h. So we've got that V is 20 times 10 times h, which is 200 h. This means that dv dh, the rate of change of V with respect to h, is 200. We also have that the rate of change of the volume, so the dv dt is proportional to 1 over root h. It's inversely proportional to the square root of h. So I will introduce a constant of proportionality k to get dv dt is k over root h, and I will then use the chain rule to write that dh dt is simply dh dv times dv dt. So I'm simply saying that to go from h to t, I will go from h to v and then from v to t. Now dh dv is simply the reciprocal of dv dh, so it's going to be 1 over 200, and the dv dt is k over root h. Now k over 200 is simply another constant. I will call this lambda, and therefore we conclude that dh dt is equal to the constant lambda over root h as required. Now we're given that initially the height was 1.44 meters, and 8 minutes later it is 3.24 meters, and we need to find an equation of the form here to connect h with t. So we have already established that dh dt is lambda over root h, so this means I can separate the variables. I've got h to the half dh is equal to lambda dt, and I'm integrating both sides. So I've got h to the 3 over 2 divided by 3 over 2. So I increase the power by 1 divided by the new power is equal to lambda t plus c. We know that when t is 0, so initially the height was 1.44, so I can substitute to get 2 times 1.44 to the 3 over 2 divided by 3 is equal to lambda times 0 plus c, and this leads to c being 144 over 125, and I will then use the second piece of information. When t is 8, we were told that h is 3.24, which means that 2 times the 3.24 raised to the power of 3 over 2 divided by 3 is equal to lambda times the t, which was 8, plus the c, which is 144 over 125. Now we get that 342 over 125 is equal to 8 lambda, and therefore we have that 171 over 500 is equal to lambda if I divide throughout by 8. Now that we've got the values for c and lambda, we can easily conclude that 2 times h to the 3 over 2 over 3 is equal to lambda of 171 over 500 times the t plus the c over 144 over 125. I can then proceed by multiplying throughout by 3 to get 2h to the 3 over 2 is equal to 513 over 500 t plus the 432 over the 125, and if I divide by 2 I get h to the 3 over 2 is equal to 513 over 1000 t plus 216 over 125, and if I compare with the form I needed to arrive at, we can easily conclude that the constant a turns out to be 513 over 1000, whereas the constant b is 216 over 125. In part C, we need to find the time taken from when water started flowing into the tank for the tank to be completely full. Well, let's start with the equation we obtained for h in terms of t. And we know that if the tank is full, this simply means that we are looking for a height of 5 because that's the height of the container. So I will be substituting. We've got 5 to the 3 over 2 is equal to 513 over 1000 t plus 216 over 125. So we get that 5 to the 3 over 2 minus the 216 over 125 is equal to 513 over 1000 t. I need to solve for t, so I will multiply by 1000 and divide by 513 times the 5 to the 3 over 2 minus the 216 over the 125, and this should be t. Now we get 18.4 for t, and therefore we conclude that we're looking at 18.4 minutes for the time taken for the tank to be completely full. In 12, we've got the number of subscribers to 2 different music streaming companies being monitored. It is monitored in thousands, and we've got NA and NB respectively. And this is the graph shown here, and we need to find the initial difference between company A and company B. So I will simply evaluate each of them when t is 0. So this means that when t is 0, then n of A is simply the absolute value of 0 minus 3 plus 4, which gives an answer of 7, whereas n of B is equal to 8 minus the absolute value of 2 times 0 minus 6. Remember, we're substituting t with 0, so we get 2. So we've got 7 minus 2 is equal to 5, and therefore we conclude that this means we've got a difference of 5,000 subscribers, because remember that the numbers are in thousands of subscribers. Now, when T is capital T, company A reduced the subscription prices and the number of subscribers increased, and we need to suggest a value for T, giving a reason for your answer. Well, if I briefly go back to the diagram here, this is NA here, and we've got something happening here at the vertex. So obviously this should be the value for capital T we're trying to find. So remember that NA is simply the modulus of T minus 3 plus 4. The vertex is always when this value, this expression within the modulus is 0. So we know that the vertex will be when T is 3, and when T is 3, the value for the Y is 4. So we can conclude that the value for capital T is 3. It's the x coordinate of the vertex. In part C, we need to find the range of values of T for which NA is greater than NB, giving our answer in set notation. So this is the diagram here. We want N of A to be greater than N of B, so we want this part and this part here, which I'm highlighting here. Remember that NA is the modulus of T minus 3 plus 4, so I could actually identify this part here as being T minus 3 plus 4, so the modulus sign behaves like a normal set of round brackets, whereas this part here that goes downhill, this behaves as a normal set of round brackets with a negative sign outside, so it's the minus T minus 3 plus 4, whereas the NB is 8 minus the modulus of 2T minus 6. So we've got that this part here is simply the 8 minus brackets 2T minus 6, whereas this part here, it's the 8 plus the 2t minus 6, and I will be equating each of these because I'm looking for the points of intersection, and we've got two of these. Now to find this part here, I'll be equating the 8 plus 2t minus 6 with the negative t minus 3 plus 4. So we've got 8 plus 2t minus 6 is equal to negative t minus 3 plus 4. So 2t plus 2 is equal to minus t plus 3 plus 4, leading to 3t is equal to 5, and therefore t is 5 over 3. Now for the other point of intersection, I will be equating the 8 minus 2t minus 6 with the t minus 3 plus 4. So I've got 8 minus brackets 2t minus 6 is equal to t minus 3 plus 4. Therefore, 8 minus 2t plus 6 is equal to t plus 1, leading to 14 minus 2t is equal to t plus 1. And therefore, we've got that 13 is equal to 3t, which means that we've got 13 over 3 for the value of t. So we know that anything that is greater than the 13 over 3 and anything that is less than the 5 over 3 and obviously greater than 0 because the horizontal axis is the time, will satisfy the given inequality. So we have the solution set to be all values of t such that t belongs to the reals and t is between 0 and the 5 over 3 union, so means or all t such that t belongs to the reals and t is greater than 13 over 3. And in part D, we need to state the limitation of the model used for company B. So we can see that company B has reached the vertex here and then goes down. So obviously at some point, if it keeps going like that, it's going to hit a negative number of subscribers, which is not valid. So since the model predicts a negative number of subscribers, this is not valid. In 13a, we need to find the first three terms in ascending powers of x in the expansion of 3 plus x to the minus 2. And we need to be writing each term in its simplest form. So we've got 3 plus x to the minus 2, and the first thing to do is factor out the 3, inheriting the power of negative 2, and within the bracket we've got 1 plus x over 3 to the negative 2. So we need to attain a form of 1 plus or minus something in order to proceed with the binomial expansion. Now 3 to the negative 2 is obviously 1 over 9. And then I proceed with the binomial expansion. I've got 1 plus the negative 2 times x over 3 plus the negative 2 times the negative 3 over 2 factorial times x over 3 to the power of 2 plus dot dot dot. This is an infinite expansion. We are only looking for the first three terms. So I can proceed in simplifying the bracket. I've got 1 over 9 and we've got 1 minus 2x over 3 plus x squared over 3 plus dot dot dot, which upon further expansion will give me 1 over 9 minus 2x over 27 plus x squared over 27 plus dot dot dot. In B, we need to use the answer to part A and algebraic integration to estimate the value of this integral, and we need to be giving an answer to 4 significant figures. So this is the integral we need to find. Well, we have already found the expansion of 1 over 3 plus x to the power of 2. So the integral can be written as the integral from 0.2 up to 0.4 of 6x. And in brackets, we've got the binomial expansion we obtained in A. So 1 over 9 minus 2x over 27 plus x squared over 27 plus dot 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 and close the brackets dx, which can be expanded to get the integral from 0.2 up to 0.4 of 2 over 3x minus 4 over 9 x squared plus 2 over 9 x cubed plus dot 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 dx. I can now expand on a term by term basis to get that this is equal to 2 over 3, and I've got x squared over 2, and then minus 4 over 9, and we've got x cubed over 3, and then it's 2 over 9, and it's x to the power of 4 over 4, with the limits being the 0.2 and the 0.4. Now this gives me x squared over 3 minus 4x cubed over 27 plus x to the power of 4 over 18 from 0.2 up to 0.4. So now it's the time to substitute the upper and the lower limit. So this is equal to 0.4 squared over 3 minus 4 times the 0.4 to the power of 3 over 27 plus the 0.4 to the power of 4 over 18. This is the upper limit substitute, and then the lower limit is 0.2 squared over 3 minus 4 times the 0.2 cubed over 27 plus the 0.2 to the power of 4 over 18. I plug everything on the calculator carefully and I get the result of 0.03304. In part C, we need to use algebraic integration to find the exact value of the same integral, and we need to be giving our answer in the form a ln b plus c, with a, b, and c being constants to be found. And one way I could approach this is through a substitution. So I will let u be x plus 3, which means that du is equal to dx. I will also change the limit, so when x is 0.2, we get that u is 0.2 plus 3, which is 3.2, whereas when x is 0.4, we get u to be 0.4 plus 3, which gives an answer of 3.4. This means that the integral from 0.2 up to 0.4 of 6x over the 3 plus x squared dx can be written in terms of u as the integral from 3.2 up to 3.4 of 6 times the x. Well, the x is simply u minus 3, so let me write in brackets u minus 3, over the 3 plus x all squared is simply u squared, and dx is du. So I can proceed into expanding. This is the integral from 3.2 up to 3.4 of 6u over u squared minus 18 over u squared du, which can be written as the integral from 3.2 up to 3.4 of 6 over u minus 18 u to the negative 2 du. Now obviously the integral of 6 over u is 6 ln u, so we've got 6 ln u minus 18 u to the minus 1 over minus 1, and we've got the limits of 3.2 and 3.4. Before substituting the limits, I will simplify my answer here. So we've got 6 ln u plus 18 over u from 3.2 up to 3.4. I will substitute the upper limit, so we've got 6 ln of 3.4 plus 18 over 3.4 minus the 6 ln 3.2 plus the 18 over the 3.2, and I close the brackets here. So this leads to 6 ln of 3.4 over 3.2 because we've got subtraction of logarithms. So the 6 ln 3.4 minus the 6 ln 3.2 can be written as a single logarithm as shown here. And we've got plus 90 over 17 minus the 45 over 8. So this leads to 6 ln of 17 over 16 minus 45 over 136, which matches the form that we had to arrive at. So we conclude that the constant a is 6, the constant b is 17 over 16, and the constant c is negative 45 over 136. Now alternatively, we could have employed partial fractions, and we could have started by saying that 6x over 3 plus x all squared can be decomposed into a over 3 plus x plus b over 3 plus x all squared. So we're looking at a repeated linear factor. So I will remove the denominators by multiplying throughout by 3 plus x all squared, leading to 6x is equal to a brackets 3 plus x plus b. Now if I set x to be negative 3, we've got 6 times negative 3 is equal to b, and therefore we conclude that b is negative 18. And if I substitute x is 0, I'll get 6 times 0 is equal to a times 3 plus 0 plus b. So we've got 0 is 3a plus b, which was found to be minus 18. So 18 is equal to 3a, and therefore we conclude that a is equal to 6. So this means that the integral from 0.2 up to 0.4 of 6x over 3 plus x all squared with respect to x can be written as the integral from 0.2 up to 0.4 of 6 over 3 plus x minus 18 over 3 plus x all squared dx. Now I will write this as the integral from 0.2 up to 0.4 of 6 over 3 plus x minus 18 times 3 plus x to the negative 2 dx. So I'm doing this to see the process of increasing the power by 1 and dividing by the new power in this second term. Now the integral of 6 over 3 plus x is simply 6 ln of the absolute value of 3 plus x minus 18 times 3 plus x to the minus 1 over minus 1, and I've got limits of 0.2 and 0.4. And before substituting the limits, I will simplify the expression here. So it's 6 ln of 3 plus x plus 18 over the 3 plus x, and we've got limits of 0.2 and 0.4. So if I proceed in substituting the upper limit, I will be getting 6 ln of 3 plus 0.4 plus 18 over 3 plus 0.4. And if I substitute the lower limit, it's going to be 6 ln of 3 plus 0.2 plus 18 over 3 plus 0.2. So again, we've got a similar expression we obtained before. So we can proceed. We get 6 ln of 3.4 plus 90 over 17 minus 6 ln of 3.2 minus 45 over 8. I will be combining the two logarithms together to get 6 ln of 3.4 over 3.2. And if I do the 90 over 17 minus the 45 over 8, I'm getting minus 45 over 136, which means we're looking at 6 ln of 17 over 16 minus the 45 over 136, which is identical to the answer we obtained through the first approach. In 14a, we need to show that this trigonometric equation given here may be written into this form with a, b, and c being constants to be found. So starting with what we are given, the first thing to do is obviously write the tan theta as sine theta over cos theta. So we're looking at 2 sine theta over cos theta times 8 cos theta plus 23 sine squared theta. And on the right hand side, we've got 8 sine 2 theta. And we see that the 1 plus tan squared theta is simply sec squared theta. So I can then proceed into writing 2 sine theta over cos theta. And within the bracket, we've got 8 cos theta. And I will be replacing the sine square with 1 minus cos squared. The reason is that we can see that what we need to arrive at involves cos squared, it involves cos, it doesn't involve any sine squared theta. So on the right hand side, we've got 8 sine 2 theta over cos squared theta, which means I can proceed into multiplying both sides by cos squared theta to get 2 sine theta cos theta. And within the bracket, we've got 8 cos theta plus 23 minus 23 cos squared theta is equal to 8 sine 2 theta. Now 2 sine theta cos theta on the left hand side is simply sine 2 theta. So we've got sine of 2 theta brackets 8 cos theta plus 23 minus 23 cos squared theta is equal to 8 sine of 2 theta. And I can collect everything on the right hand side to get 0 is 8 sine 2 theta minus sine of 2 theta, and in brackets 8 cos theta plus 23 minus 23 cos squared theta. We notice that we've got a common factor of sine 2 theta, and in the bracket it's 8 minus the 8 cos theta minus the 23 plus 23 cos squared theta. Now collecting like terms within the bracket on the right hand side will give me sine 2 theta brackets 23 cos squared theta minus 8 cos theta minus 15, and therefore we conclude that the constant a is 23, b is negative 8, and C is negative 15. In part B, we need to solve for x between 360 and 540 degrees, the given trigonometric equation. We consider it's exactly what we have been working on in part A, with theta being replaced with x. So we are looking at sine of 2x, and in brackets 23 cos squared minus 8 cos x minus 15 is equal to 0. Now this means that either sine of 2x is equal to 0, or alternatively we've got 23 cos squared x minus 8 cos x minus 15 is equal to 0. Now on the left hand side, if sine of 2x is 0, then my principal value is shift sine of 0, which is 0. So get 2x is the principal value plus 360k, or 2x is 180 minus the principal value plus 360k. I will divide throughout by 2 to get x is 180k, or x is 90 plus 180k. Whereas on the right hand side, I will be factorizing the quadratic in cos x to get 23 cos x plus 15 in the first bracket, and cos x minus 1 in the second bracket being equal to 0. So we've got 23 cos x plus 15 is equal to 0, or cos x minus 1 is equal to 0. So 23 cos x is negative 15, which means that cos x is negative 15 over 23, whereas for cos x minus 1 is 0, we've got cos of x is 1, and I can now proceed in finding the principal values. Now for cos of x being minus 15 over 23, we've got the principal value being shift cos of negative 15 over 23, which gives an answer of 130.706 ... degrees, whereas for cos x being 1, we've got the principal value being shift cos of 1, which is obviously 0. So I can proceed with the generating formulae. Now we've got x is plus minus the PV of 130.706 plus 360k, whereas for the PV of 0, we've got x is 0 plus 360k. I can substitute integer values for k to generate solutions within the range of 360 and 540 degrees. And notice that 450 is not a solution. This is simply because tan of 450 is undefined. It's one of the asymptotes of the tan graph. And therefore, if I put k is 1 here, we get the value of 360. That's the first solution. I can then proceed. If I put k to be 1 here and I do 360 plus 130.706, we get 491, which is another solution. And finally, if I put k to be 3 here, I get x is 180 times 3, which is 540, and we've got a total of 3 solutions. In question 15, we're given the start of the proof for sine of x minus cos x being greater than or equal to 1 when x is an obtuse angle. So we've got proof by contradiction. They start by assuming the opposite. So sine x minus cos x is less than 1 when x is an obtuse angle, and they square both sides, and we are asked to complete the proof. So the first thing to do is obviously to expand the bracket. So on the left hand side, we've got sine squared x minus 2 sine x cos x plus cos squared x being less than 1. So sine squared x plus cos squared x is 1, and 2 sine x cos x is sine of 2x. So this is less than 1. So we've got 0 being less than sine of 2x. So at the moment we're looking at sine of 2x being positive. However, since x is obtuse, that means we're between 90 and 180, and therefore the 2x must be between 180 and 360. So the angle is in the third or fourth quadrant, and therefore sine of 2x must be negative, which means we're looking at a contradiction because we have just obtained that sine of 2x is positive. Therefore, we conclude that if x is an obtuse angle, then sine of x minus cos x must be greater than or equal to 1.